So I'll have to be a little careful because this is an inequality. So I'm going to start by setting it equal to 0. I'm going to send this guy over the other side. So I'll have 3 over x plus 2 minus 2 over x minus 1 greater than 0. Now, got these fractions, so I want to create a common denominator. So, get a different pen. My LCD will be x plus 2 times x minus 1. And so this guy here will need an x minus 1, top and bottom. This guy here will need an x plus 2, top and bottom. Now this is an inequality, not an equation, so don't go ditching the denominator, you have to keep them. But because the denominator is the same, x plus 2, x minus 1, x plus 2, x minus 1, you can go ahead and combine the numerators. So the numerator, I have 3 times x minus 1 minus 2 times x plus 2, and the denominator is that common denominator, x plus 2 times x minus 1. And this whole thing is still greater than 0. Just cleaning up the top, I'll have 3x minus 3 minus 2x minus 4. That denominator's just staying put. Keep cleaning the top. 3x minus 2x is x, minus 3 minus 4 is minus 7 over that common denominator. So now, I do want to find out where everything equals 0. I want to know when the top equals 0 and where each of these factors on the bottom equals 0. So solving each of these, either x equals 7, x equals negative 2, or x equals 1. Just subtracting 2, adding 1. So these are the numbers that are going to go on my sign line. I have to create this sign line because of that inequality. So I'll put a minus 2, a 1, and a 7 on my sign line. And I'm not allowed to equal any of these because there's no equal sign underneath here, especially not equal to the bottoms because the bottoms would never be able to equal 0. So I'm going to put little open dots on everybody. So now it comes time to test every region. I've got to test numbers in each one of these. So if I were to start over here, plugging in some number greater than 7, let's say 10, and we're plugging that into this. So if I plug in a 10, 10 minus 7 is positive, 10 plus 2 is a positive 12, 10 minus 1 is a positive 9. Right? Don't really care about the numbers, just kind of care whether it's positive or negative. All these positives are going to make a positive. So I'm going to be plugged in a 10, I'm going to be positive in this region. So between 1 and 7, let's say I plug in a 5. So 5 minus 2, 7 is negative. 5 plus 2 is positive. 5 minus 1 is positive. Positive times positive is positive, and negative divided by a positive is a negative. So I'm negative in that region. Now I get to plug in some number between negative 2 and 1. I'm thinking 0 would work nicely. So if I go plug in a 0, 0 minus 7 is negative, 0 plus 2 is positive, 0 minus 1 is negative. The negative divided by a negative would make a positive, times a positive is a positive. So I'm positive in that region. One last region, if I plug in like a negative 5, negative 5 minus 7 is negative, negative 5 plus 2 is negative, negative 5 minus 1 is negative. Negative times a negative is a positive, times another negative is negative, so it'll be negative in that region. All right. They tend to alternate, so if you're running out of time, try one region and then just kind of alternate them. So look to see what we wanted. We wanted greater than 0, so we want positive stuff. So I'll take the positives, so this region here and this region here. So if I were to express that in interval notation, I'll take everything from -2 to 1 united with 7 to infinity. And that is my final answer.